Welcome to your channel Tenet Pro. This is part 2 video of SDWAN series. In case if you miss the part 1 video, please press on the I button so that you can watch and come back again to this part 2 video. Today's discussion topic is AAR and it is presented by Tenet Pro, all about concept. Let's get started. AAR called Application Aware Routing. So your SDWAN infrastructure is much intelligent, much automated to sense your mission critical applications and get it route for your better experience. Here I am going to explain you with a basic diagram through which I will explain how it is work. Here you can see there is one branch 1, and this is example DC. You can see this is also CH router, SD-WAN router. This is another SD-WAN router. You have one TLOC, MPLS, another one is the internet. So you have two connections, right? Now this link, as this links is more stable and with higher bandwidth, so this will be considered as a primary and this will be considered as a secondary. So here I can tell you that just give me a moment. Yeah, as you have two connections, so your SD-WAN router establishing two connections with your branch router or branch CH router or DC CH router. It's a IPsec connection it is establishing. So as you have two connections, you are establishing two SD-WAN, two IPsec tunnel, right? So there is two IPsec tunnel via two different TLOC, right? So yes, as I told you, this is primary, this is secondary, and top one is a branch. Now as I told you that application aware routing, here I have given example with the application SAP. Just imagine this is the one organization where the SAP applications is the most mission critical application which is require much, which should be highly available, right? So for that you just imagine there is one user located in a remote branch, all right, want to access the on-prem SAP were located in the DC, and it's a mission critical application for this remote branch, so that business can get smooth applications, right? Smooth operations. So here your as I told you, MPL is the primary. In that case, your application link application request will travel via the MPLS, right? Every time. But thing is that just imagine about one scenario, that is blackout and brownout. So what is blackout and brownout? Let me explain. So blackout in the sense if your link totally goes down, right? That is the blackout, right? This if the MPLS circuit goes down, right? In that case, this link automatically switch to this links. That is fine. But what about the brownout? Brownout in the sense your link is up and running, right? It is healthier link, I would say. Sorry, this link is up, but it is not healthier. The loss, latency and jitter is very high on this link, but that should be sensed, right? As application aware routing. So this link should be sensed whether link health is well or not. In that case, we have to do one thing, that we have to predefined or configure SLA, right, for this particular link. So what is the SLA? Like here we have to, as per our expectations, business expectations, we have to set a SLA for the SAP applications, that this applications maximum tolerate latency of 5 milliseconds, jitter is 2, loss is 2, and in that case the preferred color would be MPLS. And if it is not matching the SLA which is been defined, in that case it will take different route. Just see if your link is violate the SLA, right? In that case your link your SAP application or SAP application will be travel via your backup applications. So this is how it is work. So here we have to define one predefined SLA, that application can tolerate this much, otherwise it will take a backup link. So your SD-WAN infrastructure is monitor the link, right? Loss, latency, jitter, monitor the link health. Accordingly it sends the applications and send it to different link, so that it can get a good experience of the applications, right? High available applications. So here I try to explain with the basic diagram. So it's a application sends configurations, where it sends the applications, whatever it is predefined. You have to choose from there, and you have to make a one SLA which can be tolerate with your SAP application. The application could be as per your business requirement. It could be voice, video, and other application also. Here I have given the example with the SAP application, right? So once this SLA which has been defined earlier, if it is violate, it will take other link, right? So this is how it's basic stuff I try to explain. This is how it is work. Yes, for the application routing, you have to go through some thing that loss, latency, packet loss, jitter in the brownout situation, right? And it's use the BFD hello packets. So here in SD-WAN infrastructure, BFD protocol, it's not new. It's since long it is being using, and here SD-WAN is using taking the leverage of the BFD protocol, right? So I'm going to explain the BFD also. The BFD plays a major role in the SD-WAN infrastructure. Yes, you have to go through tunnel, light, color, you have to backup primary color, you have to select, and you have to configure the route policy also. For the configuration step, you just need to 3 only. Yeah, for you have to, as I told you, right, you have to select the SLA. Yeah, then you have to put one policy. Yes, policy would be centralized. This is the beauty of the SD-WAN. Centralized, use the push the policy, and if you have the 1,000 of branches, 100 of branches, it will push at a time. You don't need to go each and every branches to push the policy, right? In the main policy, you have to apply in which service VPN you have to apply this policy, right? So yes, you have to go through a few steps, and you will get a leverage of the application ever routing. Now I'm going to explain the BFD, right? As BFD playing a major role in the SD-WAN infrastructure. Let's explain with this diagram, right? Again, here I have given the example with the branch 1 and branch 2 with the 2 router, right? So BFD run in SD-WAN infrastructure. BFD runs in the internal, even it's around the link also. So for the IPsec tunnel establishment, BFD plays a major role. It's check the link liveliness, so that IPsec tunnel can be established. Yeah, that is for the IPsec tunnel. It's also play a good role in the BFD protocol. Apart from that, BFD also plays a good role or major role for the application hour routing. So in this slide, I'm going to explain how BFD works in SD-WAN infrastructure, right? So here, 2 branches, 1 IPsec tunnel. Each BFD packets, just focus on the diagram, each BFD packet sends to the next hop or next branch in every 1 second, right? In every 1 second, one BFD hello packet is sent to the near end or the branches other CH router. So it sends the link liveliness, and it sends the link health also. So what BFD contains, right? We understand the BFD, right? What contains with the BFD? What it's collect, right? It's travel within this tunnel, and it sends a lot of things. But what it's collect and what it get the informations, it's consist with or it's collect the informations. What is the loss in this link? What is the latency? What is the jitter? So in a word, we can say it sends the link health also for the application hour routing. All right. So this protocol sends the link health, link liveliness in the SD-WAN IPsec tunnel. So in SD-WAN infrastructure, the BFD collect this much informations, and BFD packets put all the BFD packets in a bucket, right? Here I'm trying to explain this thing. This bucket is collected, the BFD packet collected in a bucket, right? till 10 minutes, right? So 10 minutes is 1 every seconds, so it is 600 packets, right? So try to understand. Let me show you again. This is the BFD packet, right? This is the BFD packet. So it's collect the loss latency jitter. It's travel each of the link with IPsec tunnel, right? Then it's collect the link health information, I would say. Even it's check the link liveliness. Then one bucket created, and that bucket collected all the BFD packet till this bucket is collected with the 10 minutes. Till 10 minutes it's collected. In 10 minutes, if it is travel 1 seconds, the packet is called a 600 packet. So this 600 packet, or this single bucket here in SDWAN infrastructure called as a one pole interval or one bucket, right? So how this bucket get utilized to send the link, right? In SDWAN infrastructure or in SDWAN technology, it's always take an average, or it's always work with the 6 bucket, right? It's analyze, it's sends the link, then with the 6 bucket it's test all the things, right? It's always work with 6 bucket only. Once the 7th bucket comes in scenario, in the first bucket, the earlier bucket gets discarded. So it's mean always it's work with the latest 6 bucket, right? So always it's work with the 6 bucket, and in one bucket collect the BFD packet till 10 minutes, right? Each 1 seconds, in every 1 seconds the BFD packet sends and come back again with the information, right? Here it is also. So in 10 minutes it's collect the 600 packets. 600 packet equal to, over here we called one pole interval, right? One pole interval, we can also often send the one bucket, right? And always SDWAN here by default it is work with the latest 6 bucket, right? It analyze the 6 bucket BFD packet to understand the link health, link loss latency. So you understand how real time data they analyze to sense the link, right? Link health. Hope it is clear. I would recommend make pause and reverse and listen again. Hope it will be clear. Now this is the default configurations in the SDWAN infrastructure. You can customize these also, right? You can customize as per your requirement. If you require more real time, in that case you can customize. You can work with the 4 bucket, 5 bucket. And if your application not that much sensitive, in that case you can also work with the more bucket, right? So it's a customizable option. Here I put a one snap where it is mentioned that you can work with we can customize this thing, this BFD, right? This BFD it is customizable. By default it is 6, as I told you, right? It's this 600 packet is called as a multiplier, right? Bucket by default 6 to 2. And pole interval, as I called you, this is the pole interval, 6000 interval. You can customize, you can change also as per your requirement, right? Hope it is clear. And the second part, you have to create SLA, right? From here you can create SLA where based on your applications, right? How much loss it can tolerate, how much latency it can tolerate, you can predefine and you can configure, and that can be called in a policy, right? So as it's a conceptual video, I have not explained the exact configurations, right? The basic stuffs I try to explain. Now get to the next slide. Yes, application our routing, hope it is clear, the basic stuff, how it is work and how the traffic gets flow and how application gets sent, right? Now second is that in part 1 I try to add something. For that part 1 video I explain a few things, but I said that a few things I will explain later on also. So that two things I'm going to explain over here also. So it's a add-on point which is related with the part 1 video. So here, as I told you, I'll explain the VPN range, right? So here I have explained, hope it is understandable, this architecture. It's a, I would say, X-ray copy, a scan copy of the router, the SD-WAN router. So here this is the two TLOC, right? Internet and the MPLS, and it is connected to different interfaces. And as I told you earlier also, the VPN 0 is always called as a transport VPN. It's a kind of global routing table, global VRF. So it's called always the transport VPN, where your TLOC gets connected, and it is always VPN 0, or it should be always VPN 0. You cannot change, you cannot modify, right? You cannot change this thing. And I just remember one thing with this you cannot change, that is BFD by default enable. You cannot change, right? By default VFD is enabled in the SDWAN infrastructure. I just remember, that's what I recall this thing to you also. Yes, so VPN is also same, you cannot change. You have to always go with the VPN 0 for your transport VPN, where your connection gets terminated, right? Another is the service VPN. Service VPN is nothing but where your network or LAN network is get connected, where your user get connected, right? So earlier in part 1 video I said that I will tell you the range. Yes, for the service VPN you can create multiple service VPN, right? So the VPN number range, you can choose any one from VPN 1 to 511 and VPN 513 to 65530. This is the service VPN range. You can take any one, right? You can take any one from this range, right? But for the transport you cannot change. It's a fixed. It's a fixed. You have to go with a VPN 0. You have to always. And in service VPN you can go with the any of the numbers which comes under this range, and it's a service VPN which belongs to your LAN side, right? So here I would say this is your WAN part, and this is your LAN part, right? Another VRF is left, that is management VPN, right? So management VPN always you have to go with 512. It is standard, it is predefined, you cannot change, you can modify. So VPN 0 is fixed and VPN 51 is also fixed. You cannot change the numbers. You have to go with the this number which is prefixed. And service VPN you can change, and in service VPN this routing protocol you can run. Apart from this you can run, but it's always recommended to static route OS paper BGP. Yeah. So this is one thing I missed in the part 1 video. That's what I just highlight. So that's what it is called as a part 1 add-on points. Now second part is that I commit that I will tell you, that is the color part, right? So here I told you multiple colors is been predefined. One is the public and one is the private, right? Private always mean to your private link, right? And public is always mean to your internet link. And for the color perspective, just imagine if you have three internet connection, right, in a single router. Just yeah. So here first color you can go with the 3G. Second color you have to mention with the LTE. Third you can mention the B's internet, right? If you have the 3 internet connection. Yes, if whatever the connection you have to choose from this range any of the color in your connection which is belongs to public network, right? So if you have 2 connection you can choose green and red, right? If you have 3 connection you can choose gold, silver, bronze, anything you can choose from here. It belongs to public. And as it is likewise private color also you can choose from here. If your connection is the P2P connections, if your connection is the MPLS, right, or any metro ethernet, you can choose from any color. Apart from this, there is other color which is not might be mentioned, that is custom 1, custom 2, that is also one color. So this is the color you have to go with, right? It's predefined. You have to choose from the drop down box whenever you do configure. So yes, for the part 1 add-ons, one thing that is the VPN range, and second is the transport VPN range and the management port VPN range. Yes, hope it is clear, right? Hope it makes sense, and it is expected, and I hope it's informative. Your time paid you whatever time you have invested. So yes, as I every time it's every time says that it's a video communications, it's a one-on-one communications. So if you have any doubts, if you have any query, if you have any suggestions, please put and comment and let me know. And yes, I will come to second part also of this video series. So for that, please press on the bell icon so that you can get notified. Yeah, thanks for your time.